so let's pull back up the practice scenario and we'll finish going through that. We got to what? The markup stuff, I think. Is that where we got to?
Why is there no parking out there?
There is probably a continuing education training going on for like, it could be, usually if you see a lot of law enforcement out there, it's one of those, but I don't know, it could be something unrelated to that. But
Park on the side of the road.
yeah, usually that's what happens is that there's some sort of continuing education thing, gets a lot of folks here. So we did this one, right? Do I add that one to your notes? Okay. What about this one? Have we done this one yet? The Christmas wreath?
No.
All right, let's do that one then. Okay, so we're going to try to go through these pretty quickly so that we can look at the actual lab itself. My goal is today, finish this, go over the lab, and then hopefully on the first class of next week, we'll do a test review, and then what I'm going to try to do, which I haven't been able to do in a long time, but what I'm going to try to do is I'm going to try to lock the test for my in-person classes so that you can actually take the test in here on Wednesday. That way you can just go ahead and knock it out, because I've been getting a lot of people that just aren't doing the tests, so I'm going to try to see if that'll fix it. But we'll see. All right. So you purchase Christmas wreaths to sell at $11 a wreath. That is your wholesale price. So keep that in the back of your mind. To make a profit, you mark them up 182%. So there is your markup. Find the new selling or retail price. So that is the one that we're looking for. All right. So we go to the retail formula then. So it's retail equals wholesale. You can also use cost if you want to use that. The pen program's still asleep. So retail equals wholesale times 1 plus % markup. All right? So we have the markup, we have the wholesale, we don't have the retail price. So that's what we're going to be looking for here. All right? The wholesale is $11. The markup is 182%. So that's going to be 1 plus 182%. All right? So from here out, it's inverse operations and simplification. So the first thing that we're going to do is we're going to divide, oh no, wait, sorry. I'm thinking of wholesale. My bad. My brain's not caught up yet. Sorry, no. Never mind, scratch that. But we're not doing inverse operations. That's for finding wholesale. We're finding retail. See, I'm so used to finding the original price on everything because you've got more of those. And it happens to me too. Sometimes when the easy ones pop up, you're already in hard mode and it's hard to adjust. So yeah, you don't have to do that this time. You can just say, all right, well here's 11. I'm going to turn 182% into a decimal. So 11 times 1 plus 1.82. Because when you turn a percent to a decimal, it just moves it 2 places over to the left. Then go ahead and simplify solve what you got in your parentheses. So 11 is now multiplied by 2.82. And then multiply that, finish it off, tell me what you get. I have lost my calculator. Oh wait, no, it's in my office. 3102. Everybody else get 3102? All right, good. Yeah. So now this question won't show up on the lab, but let me just ask you as an extension, is that a good markup? If you think about how much they're going to sell for, which is your retail, compared to how much she paid for them, or how much you paid for them, I guess, is that a good markup? Anything that's considered like good is at least 100%, at the very least. So yeah, She's spending, for every $11 that she's spending, she's making $21.02. Now normally you would try to like avoid that kind of weird amount of cents there. So like 182%, that's, you know, that's an odd one. Sometimes though, maybe there's a corporate markup, right? You know, like branded things like, you know, Disney or Marvel or stuff like that. If you're trying to find that kind of stuff, like say if there's, like this has happened in my own experience, trying to buy like a new lunchbox for school, all right? One is like, just has like generic pictures of dinosaurs or cars or things on it like that. But the other one is a Disney one that has dinosaurs from the movie Dinosaur or cars from the movie Cars on it. That one's going to be more because it has a corporate markup amount, right? Because they're going to get a piece of it too. So maybe that's what that is. Maybe this is like a Disney wreath or something, and she was initially just going to mark it up 150%, but then Disney said, no. That's not enough. We want our cut too. So that's why they said, you know, mark it up even more. Could be, maybe not, you never know, but that's just another possible explanation for a weirdo percent like this. So that is markup to find retail, or in other words, this is the easy version of the markup problems. All right? Anybody need to finish copying that down or get a picture of it? All right, are we good? Can we keep going? All right. So we'll make sure y'all got enough time to get it copied down. Okay. So here is markup to find the percent of markup. So if the one we just saw was the easiest version of these, this one is, some say difficult, I say weird, because it is just a weird type of problem. So you bought bookshelf kits at $30 a piece. So if you bought them at $30, that's your wholesale, right? You're going to sell them at $54. That's your retail, okay? What was the percent markup? All right, so that's what we're having to find. So go back to the formula. Retail equals wholesale times 1 plus your percent of markup, okay? Next, put in what you know. So you know that the retail is 54. You know the wholesale is 30. What we don't know is the percent markup, right? Okay, now you start doing inverse operations. I got ahead of myself a while ago. So you're going to divide both sides by 30 to kick it off, all right? So when you do that, on the right side, you're just going to have the 1 plus percent M left. And then what's 54 divided by 30? It's not much.
1.8.
1.8? Okay. Is that what everybody got?
Yes.
Good. All right, 1.8 it is. All right. Now you're trying to isolate your percent M because it's kind of acting like your variable. So it has a 1 being added to it. You have to take it away. Okay? So now the left side is just going to be 0.8. The right is going to be percent M. And I wish there was like a quick, neat way to sort this out. But the way we're going to do it is we're just going to say, okay, we know that this on the left, the 0.8, needs to be a percent. So to make that a percent, we're just going to multiply it by 100. It's an equation, so multiply both sides by 100. And through the magic of mathematics, that's going to take that away. So now you're going to have 80% equal to M. All right. Now let me ask you this. Same thing I asked you on the last one. Is that a good markup percent? No. No. Because for every $30 that she spends on these bookshelf kits, she's only making 24. She's losing $6 on each of these bookshelf kits, right? Argument could be made she paid too much for them, right? because 54 for a bookshelf, depending on how big it is, I mean, that's about right anymore. But if she paid 30 for them and she's only selling them that much, she's not making any money off of them. She's actually losing money on every one she sells. Now, maybe there's some information we don't know. Maybe she did have them priced higher and she had to mark them down because they weren't moving. Maybe they're ugly, you never know. But at this rate, she's not making any money off of them. All right? Everybody got all this? Okay. All right. Finding a change in salary. Bill's new salary is $15 an hour. He found out that this is a 2% bump up from last year. What was last year's salary? This is along the same lines as those population problems. Number 17 off of the student copy for Percent Lab 1 in particular. So if it's a bump up, that's addition, right? So we're going to go with the added percentage formula here. And we're looking, when it says last year's, that is the old one, right? All right, so write your formula. New equals old, bless you, plus percent of old. Since the old one is the one we don't know, that's going to get our variable. The new one was given right here, so the new one is 15, so that'll go here. The old one, we don't know, we're going to call it X. We have the percent of 2%, so 15 equals X plus 2% of X. And the quick way to go about this, treat that like 1X and turn 2% into a decimal. So we'll have 15 equals 1X plus 0.02X. Combine like terms, 15 is equal to 1.02x. And then to finish it off, divide both sides by the 1.02. And that will give you what last year's salary was. $14.71. Yeah. All right, we get a second on that one? Yeah. Good. All right, good. $14.71 is correct. Yeah. So again, working backwards to find the original. The reason why you've got so many of those is because that's the one that always gives people the most trouble. But like I said earlier, when I started to do that first one we had today incorrectly, you get so used to finding the original price that when it comes up to where you actually have to work the formula the way you're supposed to, it's, throws you off a little bit. Any questions about this one? All right. Moving right along. Okay, calculating overtime. So I got this split up into two parts. Now when you see this type of question on the lab, it's all going to be put together as one question, but I've split it into two for now because this question has two things that you have to do. So we'll just tackle it that way. All right. Robbie currently makes $20 an hour and gets time and a half for all hours over 40 that he works in a week. He worked 46 hours last week, so how much did he take home? This one was the one I was telling you earlier this week. We don't have a formula for it. We have to make it. All right? So the way that it works is you're looking for when it says just based off this information, how much did he take home? So you're figuring out his wages and his time he put in. That's called, oh, for Pete's sake, come on. Just because I didn't turn a marker on. That's called your gross pay. All right, I don't know why they call it that, but they do. All right, so here's how you get it put together. So $20 an hour, and then it says time and a half for all hours over 40. So you've got two amounts of hours that are earned at different wages. All right, so the $20 an hour goes with the 40. All right, so the first part of this is just $20 an hour. So it's your wage times the time you put in, which is 40 for, full time. All right, and then it also said, and gets time and a half for all hours over 40, and he worked 46 hours last week. Now, the mistake that most people make with these is they don't take 40 away from the 46, because it just says all hours over 40. The mistake they make is they say, all right, 20 times 40, and then the time and a half times 46 times 20. No, that's not going to work. Okay, so the first thing we do is you include his normal wage, all right, which is $20 an hour, and then you've got to factor in the time and a half. Does anybody know how to, what percent that would be? Time and a half. If you've worked overtime, do you know what percent time and a half is? May not know off the top of your head. It's 150%. All right, so 150 because it's it's all of your normal pay, so 100% of your normal pay, and then half of it added into it. So it's 150% of your normal wage, and that is what the overtime hours get earned at. All right, so we'll need to turn 150% into a decimal for this next part. Okay, so 20 times 40 plus 20 times 1.5 times 6. Now it's just order of operations. All right, do all of your multiplying before you do any of your adding. Okay, so the first part, the 20 times 40, that's 800, right? And then what is 20 times 1.5 times 6?
180.
180? Good. All right. So then, to figure out his gross pay, just go ahead and tally that up to be $980. So 800 is how much he makes a week, and then the time and a half for the 6 hours comes out to be $180. So you put that together for his gross pay of $980. All right, so that's the first part. All right, so let me do this, because I'm going to leave the rest of it. All right. Now, that is just the first part of this question. If this was the only thing that this question was asking, that would be for sure your answer. But since the one on the lab is in two parts, that is not your answer. That's the first thing you have to get your answer. Okay? So that leads me to this next part. Let me grab this. See if I can. There used to be like a selection tool or something around here, but I guess not. Nope. Ah, well. Okay, well, just remember that it's 980. All right. After Robbie found out how much he was going to make after his overtime, he remembered that he gets 30% of his check held out for various fees. Things like taxes, retirement, maybe there's a mortgage, maybe there's some other sort of monthly payment that comes out. So knowing this, how much did he really take home? So that leads us into something called your net pay. All right? So your net pay is your gross pay minus your deductions. Okay? So in other words, the net pay, oops, that don't really look like much of an end, does it? All right, is the 980, and then it says 30% of his check. Excuse me, so 980 minus 30% of 980. Well, what's that look like? That looks familiar, right? That looks like the subtracted percentage formula, doesn't it? It's called a TIS. It's just a variation of it, all right? It's a variation of the subtracted percentage formula. So change the 30% to a decimal. So you've got 980 minus 0.3 times 980. And then what is 0.3 times 980? It's a lot.
294.
Yeah, that sounds right. Someone else check me on that?
Yes.
Okay, good. I thought that's what it was. I just want to be sure. Okay, so 980 minus 294, so his earnings for his time minus how much he gets held out of his check. So what does that mean that he really took home? 686, yeah. So if he hadn't put in the overtime, the 30% would still come out. It would just be coming out of the 800, right? So, good thing that he did. Okay, so like I said, on the actual lab itself that you have that this pertains to, it's all one question. So you'll have to do two things on it to get your final answer. And then your the number that you get for your net pay, that is your answer. All right? Anybody need to finish copying that down and get a picture of it? Okay. All right. All right, so that's the end of that. Okay. So let's close that. And let's go ahead and pull up the Critical Thinking Lab 2 student copy. All right. Okay. So, your scenario, you run a general store and are faced with various percent-based scenarios. Follow your notes on percents, sales tax, percent change, discount and markup, and answer each question to the best of your ability. So what we're going to do is we're just going to run through these real quick, and we're going to, point you in the right direction. Not set it up for you. Just tell you, which formulas and things that you need. So number one, the cost of a box of supplies is $325. You were told that this is a 25% reduction from last month's cost. What was last month's cost? So first of all, what formula do you need? Which one? Subtracted percentage, right? So this one is going to be subtracted percentage, and then what is it asking you to find? Last month's cost, which in the formula, what part would that be? New or old?
Find the original.
Original, yeah. So subtracted percentage for the original. All right. And in this case, the original would be last month's cost. All right. Good. Number two, your salary is $29 per hour. You were told that this is 12% above the national average. What is the national average? So first, what formula do we need?
So the one with the increase?
Right, the added percentage formula. Very good. The added percentage formula. And which part are we trying to find, the new or the old?
The new? No? No.
Yeah. So if it says you were told this is 12% above the national average, what is the national average? So that is the original. So it's added percentage for original. All right. Whew, my handwriting's bad today. 3, your current salary is $18 per hour. You were told that you will get an increase to $25 per hour. What is the percent increase? So what formula do you need?
Percent change.
Right, percent change. So percent change We're just going to leave it at that. Can't tell you too much more or I'll wind up doing it for you. All right, so number 3 is percent change on the student copy. Let me be clear, just because you pull it up on Moodle doesn't mean that's going to be number 3 that pops up there. All right, so subtracted percentage for original, added percentage for original, and percent change. Let's look at the next batch. Okay, 4, you get an estimate to paint your store of $2,850. You were told that this is 18% below last year's cost. What was last year's cost? There's a typo in there, but I inherited these problems, so I'm not responsible for the grammar errors. All right, so which formula do we need on number 4? Discount formula or the subtracted percentage formula, right? And then what are we trying to find? The original price, yeah, because that's going to be what last year's cost is acting as, right? So subtract the percentage for original on number 4. 5, the retail price of an item, what you're selling it for, is $175. Your store has a markup of 285%. What is the wholesale price, or what you bought it for? So what formula do we need? Markup formula. Markup formula. And which part of the markup formula are we trying to find? The original or wholesale, right? Which wholesale is in the place of the original, so if you want to call it original, that's fine too. So markup formula for wholesale on that one. Good. Number 6, the normal price of an item is $220. It is currently on sale for 35% off. The sales tax is 8.5%. How much would a customer have to pay total for the item? All right. So what formula do we need? Subtract the percentage formula and right, you're going to need them both because this is a two-parter. So first, you're going to need subtracted percentage, and this time it's going to be subtracted percentage for the what you'll call the discount sale price, or in other words, the new price. So subtract the percentage for discount sale price, then the added percentage for final price. We'll just phrase it that way. I don't think that's going to hurt nobody. Right, so first you need the subtracted percentage for the discount sale price, then the added percentage for the final price. All right? Anybody still need to copy those down? It'll be on the video. All right. 7. The retail price of an item is $38. The wholesale price of the item is $8.50. What is the percent markup? So what formula do you need? Markup formula. And what are you looking for? Right. So markup formula for the percent markup. Markup formula for percent markup. So that's the weird one. All right. 8, 9, and 10. Okay. 8, you currently make $16 per hour, and you get time and a half for all hours over 40 that you work in a week. The company withholds 30% from your check. If you worked 58 hours in 1 week, what will be your take-home pay? So this one is the one that does not have a formula. You got to build it on your own. So the first thing you do is you have to find the gross pay, then find net pay. All right? And then net pay is what you would say your answer is for this. All right? Number 9, the wholesale price of an item is $25. If the store has a markup of 315%, what will be the retail cost? So what formula do we need? Markup again. And what are we trying to find here? Right. So this is the easy version. Markup for retail. You can't even tell it that says retail. Gollies. Sometimes this program works great, and sometimes it don't. It does not work well for fast riders like me. Yeah. Number 10. The store buys the part for $43, sells it for $115. What's the percent markup? So last time, what's the formula we need? Markup. And what are we trying to find? Right, so markup for percent markup. Okay. So, yeah. So my plan for next week, on the first day of class that we have next week, is we'll just be doing a test review. I don't really expect that to take the entire class. It'll take a good chunk of it, but it won't take the entire class. And then I think what I'm going to do is I'm going to lock the test. Well, no, I don't want to do that because then you guys won't get the full 8 days to do it. Yeah, I'm not going to do that. Tell you what, I'll leave it. I'm not going to mess with it. If you want to start the test after we do the review, that's fine. But on the second day of class next week, which will be the Wednesday and Thursday classes, we'll just be doing another working lab, and you can come in here and take the test if you haven't taken it yet. All right, or at least start it. If it takes you more than 50 minutes, you're more than welcome to stay in here after class is over and knock it out. Or if you need to go to the library, you can do that too. Sound good? Because I'm really trying not to start new lessons while there's a test open. Because like I said, historically, it causes people to forget about the test. So really trying my best not to. But all right. Okay, so yeah, a little bit of a shorter class today. We covered most of the ground on the first class of this week. So any last minute questions about anything? One last thing, I got finished coding everybody's percent lab 1s. If you are going to redo that for a higher grade, you need to let me know and complete it before the 24th. All right. Now, the reason why I say that, and I think I didn't put this in all the announcements, just the ones where just the classes where this was an issue. But I did have some classes where, like say, for instance, last night was the deadline to redo the conversions test, right? I had someone that did not request the redo of the conversions test until like after 8 o'clock. I had several people do that actually. And I don't get any messages after 8 o'clock. Plus, you've had a week to request a redo, right? So if you're going to redo something, sooner rather than later. Definitely before I don't get any more messages after 8 o'clock. All right? So, just don't let that happen to you. And, and two, another thing that had happen, give yourself enough time to do this, but don't wait too long, if that makes sense. I have had across my classes, people waited too late to start it, and it timed them out. And when it times you out, it auto submits. Yeah, that's been happening a lot this semester. Honestly, more than it should. And that's why on some of the announcements that I sent out to the classes where I had a lot of folks that didn't turn it in, I said, if 8 days is not enough time for you to complete an assignment. Maybe we need to talk about, how this class maybe isn't for you. But, like I said, it's not happening everywhere, but it is happening some places. So, I told the ones that needed to hear it. I was nice. I was. Believe it or not, I was nice. But we'll see how long that lasts. All right. See y'all next week.